Okay, last week a few were asking me how, with this crown moulding, can we turn it 90 degrees? So, return it along the adjacent wall, something like that. So, I've loaded my crown moulding back into Blender. I'm sorry, I haven't kept the original file for some reason. Or if I have, I'll put it somewhere I can't find it, which is typical of me. But never mind. So, I've loaded this back into Blender. Let me just go into a top view. So, we're looking straight down from the ceiling onto the crown moulding. If I highlight it might be easier to see. Okay, now what we want to do, we've got a wall down here. Imagine we've got a wall coming across here. We want to return this as one piece along this wall. So we want to return it at 90 degrees. Okay, now a few of you suggested just rotating this by 45 degrees. So if I rotate, I don't know, somewhere around 45 degrees there. Okay, now let me just shorten this up a bit, because the effect is easier to see if it's shorter. Okay, now that it's rotated, you can see that it tapers inwards. Okay, so that's not the answer. So let me just Control Z a couple of times to get back to where I was. Okay, as we turn this, we need this to get longer. Okay, so we need to use mathematics to find out how long. Now I know we all hate maths, I certainly, but this one's actually not too complicated. So let's just get a pen here and let's do some of the maths. Okay, so just swapping over between the mouse and the tablet. So let's find my, there we go. Right, if we have, disregard that, let's draw this out again. We've got the end of our crown moulding, okay, and we need to make a 45-degree angle so we can extrude it out this way. Okay, now if we're using this grid as a reference, the Blender grid, we can say that this is 1 unit wide and this is 1 unit high. Okay, and we need to find how long this is going to be. That's a question mark, not a 2 with a dot. Okay, so we know from Pythagoras, say we call this side A, we call this side B, and we call this side C. We know from Pythagoras' theorem that a squared plus b squared equals c squared. Okay, so we know a is 1 and b is 1, so the square of 1 equals 1. Okay, so 1 plus 1 equals 2, square root of 2. Okay, because to find it we need to find the square root of c. Okay, so if we go to calculator, and it's down here somewhere, there we go, we got 2, we find the square root, which is there, we got a figure of 1.14, sorry, 1.4142. Okay, so let's come back to this one. Yeah, need to, there we go, 1.4142. Now if you don't like maths, you can just take my word for it and forget about all of this and just remember this figure here, 1.4142. Okay, now that we have that figure, we know that we need to increase this dimension along the x-axis, because this is the one that's going to turn, by 1.4142. So we can scale with the S key, x for the x-axis only, 1.4142, enter. Okay, now we can rotate this round by 45 degrees and our sides remain parallel all the way up. Okay, so now we've got that half the angle done. All we need to do is extrude this along the x-axis to bring it out. Okay, and there we have a corner, but we also have this corner here. We need to straighten this up. Okay, we know that this is all perfectly parallel, so all we need to do is bring all these vertices into line on the x-axis, scale them to 0. Okay, so scale SX, sorry I pressed the wrong key there, SX 0, and there we have it. we have a perfect 90-degree angle, all joined in and returned. So just remember that figure, write it down somewhere, 1.4142.